Imagine the race to build the future of AI. You might think it's all about, you know, brilliant algorithms or maybe those groundbreaking new chips. Beat. But what if the real advantage, the thing that really matters, is something way more fundamental, like an electrical plug?
Yeah, like literally about having enough juice to keep the lights on. And then some. It's maybe less about the code, more about the current, right?
Welcome to the Deep Dive. Today, we're looking closely at a really fascinating, honestly, a bit unsettling observation from some top AI researchers who just got back from China.
We're going to unpack how something as basic, as foundational, really, as energy infrastructure is, well, quietly deciding who's actually going to lead this AI revolution. It's a real eye-opener. Kind of shifts your whole view.
We'll compare the energy strategies, the very different paths taken by the U.S. and China, see how that impacts AI development on the ground, and then think about what this gap means for all of us. Okay, so let's dig into this observation. A group of pretty respected AI researchers from Silicon Valley, they recently toured China's tech hubs. And they came back with this one sentence that should really, make people pause.
And it's a powerful sentence, yeah. Everywhere we went, people treated the availability of energy as a given. Just think about that for a second. Can you even imagine that mindset here? In the American AI scene, it's just not how it is.
It's almost unthinkable here, isn't it? But over there, for those developers, just solved, done. And that simple statement, when you really let it sink in, it exposes a pretty uncomfortable truth about this whole tech race narrative.
Yeah, and what's really wild, maybe a little alarming, is the implication, right? That the biggest technology race of our time might not be won by the smartest algorithm or the fastest chip. It could actually come down to the electrical grid, the literal foundation.
So while the U.S. has been, caught up in debates, fighting these ideological battles over energy policy, China's been quietly, methodically building this incredibly solid foundation for its tech future. Almost invisible, but powerful.
Right. Their AI devs, they can innovate with this freedom, They don't have to worry about the power bill spiking or if the grid can even handle their next big model training run. Meanwhile, you've got American teams seriously considering building their own private power plants or constantly having to plan around potential outages. It's a different world.
It really suggests this race, which we often talk about in terms of like software and ideas, might actually be decided on a very physical level, an area that arguably America hasn't focused on nearly enough. So this isn't just about the chips or the code then.
No, it's really about the fundamental power grid. That's the bedrock.
Okay, this is where it gets really interesting. The difference isn't just scale, though the scale is huge. It's philosophy. Our U.S. grid, it operates on what experts call an incredibly thin reserve margin, often just, 15%?
Yeah, 15% above peak. It's like running a restaurant that's always like one big table away from running out of food entirely. Every heat wave, every unexpected spike, it pushes the system right to the edge. That's why we see outages. It's designed for efficiency, maybe, but not resilience, not foresight.
China, on the other hand, totally different approach. They went for strategic abundance. Their generation capacity is nearly double their peak demand. Just let that sink in. Double.
And that's not waste, right? It's a deliberate strategic investment for the nation. This massive energy surplus means industries that need tons of power, especially AI data centers, they aren't just tolerated, they're welcomed. They're actually useful.
Right. What we see as a huge strain here, a new data center can actually help balance their grid over there. It soaks up excess power.
And the scale is just mind-boggling. China's increase in electricity demand each year is more than all of Germany uses in a year. And just a couple of their provinces generate as much power as the entire country of India. It makes you rethink what national infrastructure even means.
And they did this through serious long-term planning, building thousands and thousands of kilometers of these ultra-high voltage UHV transmission lines. These things are amazing. They carry huge amounts of power over long distances really efficiently, moving it from, say, remote dams or solar farms right to the tech hubs.
Meanwhile, back in the U.S., just upgrading one old transmission line can take, a decade? Maybe more. You get stuck in regulatory battles, lawsuits, local opposition. It's just a quagmire.
So it's not just about making enough power. It's also that we struggle to actually get the power where it's needed most. So China plans for abundance, basically, while the U.S. operates closer to the edge.
Essentially, yeah. One builds surplus, the other struggles with limits.
And now generative AI comes along, and it has created this unprecedented thirst for energy, as people are calling it. It's not just about computation anymore.
Oh, absolutely. Training just one of these big models, these LLMs, large language models. AI trained on huge amounts of text and data, like GPT-4. That single training run can use as much electricity as hundreds of homes do for an entire year. And that's only the training part.
Right, that's the key point. Because the ongoing part, the inference, that's when the AI is actually working, answering questions,
Yeah.
generating stuff for billions of users that uses even more power constantly, day in, day out.
McKinsey did the math. They figure the world needs to invest something like $6.7 trillion in new data center infrastructure by 2030. And when you see China's energy situation, well, they look uniquely ready for that kind of demand, don't they?
Definitely. And here in the U.S., we're already seeing this
Yeah.
this tension, this battle for energy between the tech giants and just regular people.
Yeah, like in Ohio, reports say families are paying on average $15 more a month on their electric bills. Why? Partly because these huge data centers came in and sucked up so much power, it drove up the wholesale prices for everyone.
Wow. And in Virginia, Data Center Alley, where so much of the world's internet traffic flows, the main utility, Dominion Energy, actually had to pause new data center hookups for a while.
Mhm.
They were genuinely worried the grid just couldn't handle any more load.
And think about California, Texas. They keep issuing these flex alerts, right?
Yeah.
Asking people, begging them, please use less electricity so we don't have blackouts. Meanwhile, the big computing facilities, the AI engines, they're running full blast. It's a stark contrast.
I have to admit, hearing about how fragile our own grid is becoming,
Mhm.
I still wrestle with how we let our foundational infrastructure get to this point.
Yeah.
Yeah, it's kind of a sad reality. How did we get here?
Well, our grid, the American grid, it was mostly built for a different time, right?
Yeah.
Industrial era. It's just buckling under this digital revolution that it was never really designed to support. It's a fundamental mismatch.
So is our aging grid simply not built for this digital era?
Yeah, it's buckling under these unexpected digital demands. Mid-roll sponsor, Reed.
Okay, so this huge difference in the grids, as we've been saying, it's not just about wires and power plants, is it? It feels like a symptom of something deeper, rooted in really basic differences in how the two countries run things, their economic models, their governance.
Yeah, totally. On the U.S. side, you often hear about short-termism, right,
Right.
and shareholder primacy. CEOs, entire industries really, focused intensely on those quarterly earnings reports.
And when that's the main focus, big long-term projects like power plants, new transmission lines, they just don't look very appealing. They cost a ton of money up front, take ages to build, and the payoff is way down the road.
Yeah,
That's a tough sell when you're worried about next quarter's numbers.
exactly. And Silicon Valley's venture capital world, pretty much the same logic, scaled up. Billions pour into software companies, SaaS companies, hoping for that 10x, 100x return in like 5 to 7 years. No VC fund has the patience for a hydroelectric dam. It just doesn't fit the model.
And the result, some argue, is what they call an extraction economy. Instead of plowing profits back into R&D or long-term capital spending, CapEx, for future growth, corporations often prefer stock buybacks, inflate the share price, pay out big executive bonuses.
It's like the phrase someone used, preferring to be emperors of a dumpster fire rather than putting in the slow, hard work of building something sustainable. Ouch.
Right. China, though, operates very differently. The government, through these big five-year plans, directs money into sectors they see as strategically vital, often years, even decades, before the demand fully shows up.
And you have these massive state-owned companies, SOEs, like the State Grid Corporation. Their job isn't just profit. They have a national mission to fulfill. It's a different mandate.
They accept that maybe some big projects won't pay off immediately or might run under capacity for a while. But that's seen as a necessary cost, a strategic bet to make sure the capacity is there when the country needs it.
Yeah.
It's basic long-range planning, isn't it?
Absolutely. And that difference helps explain why here in the U.S. you see powerful lobbies like oil and gas actively working against renewable energy development, even when solar and wind are getting cheaper. They're protecting those short-term quarterly dividends.
And while that's happening here, China's just building the infrastructure for the next century. So it really is a clash between short-term gain and long-term national interest.
Essentially, yeah. Quarterly reports versus strategic national planning.
And then there's another layer, another barrier, particularly frustrating for the U.S., the politicization of, well, almost everything. Renewable energy isn't just discussed in terms of economics or strategy here. It often gets tangled up in the culture wars.
Right. We're still having fundamental debates about climate change, so proposing a new wind farm or a big solar project, it often gets framed as a political statement, an ideological battle, rather than just a practical decision about energy or security.
China just isn't caught up in that same way. They don't seem to treat renewables as some kind of moral issue. For them, solar and wind, they just make sense.
Mm.
Economically, strategically, helps with energy independence, cuts reliance on imported fuel. Simple pragmatism.
So they just build them
Yeah.
at a scale and speed that's honestly staggering. And pragmatically, if renewables can't quite keep up with AI's crazy growth spurt, they'll fire up reserve coal plants. They see coal as, old tech to be phased out, not some kind of pure evil. It's a backup.
It's that pragmatic focus, isn't it? Lets them concentrate on getting results, building capacity, instead of getting stuck in endless ideological fights.
Yeah, and compare that to the U.S. permitting process for any big infrastructure project. It can take forever.
Hmm.
NEPA, the National Environmental Policy Act, started with good intentions, sure, but now it's often used by all sorts of groups to sue, delay, stall projects for years, sometimes decades.
While China, with its more centralized system, can push through massive projects like the Three Gorges Dam and the time it takes us just to finish the paperwork, the environmental reviews. Does this mean ideology really hinders progress in the U.S.?
Yes, I think it's fair to say partisan divides definitely stall practical infrastructure development.
So this energy difference, it's not just some abstract economic issue. It hits AI engineers and researchers right where they live, in
Yeah.
their daily work. It affects their freedom to create.
Oh, absolutely. Let's paint a picture. An American AI developer, maybe at a startup in Palo Alto, they're spending a lot of their brain power just optimizing code to use less energy. Their access to computing power, to those essential GPUs, graphics processing units, the workhorses of AI, it's limited by electricity costs, by grid availability.
Right. So if a big model training run fails, it's not just lost time. It's a serious hit to the budget. A big electricity bill they might struggle to pay.
Exactly. So they might use an AI tool, like Claude maybe, to help them optimize, crafting these really detailed prompts like, okay, how do I reduce the GPU memory, cut computational costs, make data loading faster, convert this model to run more efficiently during inference? That's when the AI is live, doing its job.
The whole focus becomes efficiency, conservation, doing more with less. American developers end up using their talent to solve problems caused by shaky infrastructure instead of purely pushing the frontiers of AI itself.
Okay, now picture an AI lab in Shenzhen. Energy is plentiful, it's cheap. Those researchers, they can chase the wildest, most resource-hungry ideas they can dream up, no hesitation.
They can train bigger models, way bigger, on more data. Experiment with super complex ideas without constantly checking the electricity meter. Failure is just part of the process,
Hmm.
a necessary step in discovery, not a potential financial catastrophe.
Right. So a researcher there might use a powerful local model, say Baidu's ErnieBot, for something truly ambitious, like maybe prompting it to generate an entire 3D virtual world from a classic novel. Simulate 400 characters with unique personalities, create storylines that emerge on their own, even try to recreate smells and textures.
The focus there is just scale, ambition. When energy isn't the bottleneck, when it's just there, the only real limit left is imagination.
Slight pause, tone of
Right.
wonder. Whoa, seriously, imagine that. Creating a whole virtual world, smells and all, just because you can. Because the power bill isn't even a factor. It's
Yeah.
like having infinite Lego bricks of data to stack. What does that unlock?
It unlocks a huge amount. It means they can often just brute force problems, try things out, push boundaries in ways their Western counterparts have to find clever, often smaller scale workarounds for because of those energy limits. So energy constraints directly limit the scope of innovation.
Absolutely. It fundamentally shifts the focus from pure discovery towards optimization and making do.
So this whole AI race, maybe without anyone really intending it, it's become this massive stress test for different national development models.
Yeah.
And the results so far, especially looking at the U.S., well, they show a system facing some serious challenges, failing in some key ways.
Yeah, and it's crucial to say the issue isn't a lack of brilliant people or innovative ideas in Silicon Valley, right? The talent is there. It's the foundation they're trying to build on. It's, as someone put it, a decaying physical foundation.
Hmm. We've sort of seen this pattern play out before, haven't we? U.S. companies getting really good at optimizing for individual wealth extraction, while competitors abroad focus on building systemic advantages.
Right. We tend to celebrate things like tax cuts, deregulation, focusing on maybe short-term boosts, while China is making these huge long-term bets on collective capability, beating the system itself.
And this energy situation, this AI race, it's really exposed a truth that maybe many Americans don't want to face, that maybe our entire model is broken in some fundamental ways. It's hard to compete long-term with nations that can actually plan beyond the next election cycle, that can invest strategically for decades.
The grid tells the story, doesn't it? It doesn't lie. It shows that decades of maybe short-sightedness, prioritizing immediate profits, have left the nation struggling to power its own future innovations. China saw this coming, and they basically solved their energy supply problem years ago, strategically.
And here, well, here we're sometimes still arguing if spending money on basic infrastructure, something everyone needs, is somehow socialism. It feels like we're stuck in the wrong debate sometimes.
We really could be watching the beginning of a major shift in technological power, a shift that's going to define the next 100 years.
And unless America really changes course, fundamentally rethinks how it balances that immediate individual gain against long-term collective investment,
Mhm.
we're likely going to keep falling behind in these crucial future races.
Yeah, the big question isn't really can we catch up anymore? It might be, are we even capable of trying when the system itself seems to reward the very behaviors that got us into this situation?
Does this mean the core system needs reevaluation, not just tweaks?
Yes, I think it points towards needing a fundamental shift in our national priorities.
So the big idea here, crystal clear, the AI race.
Mm.
It's not just about the smartest software or the fastest hardware, not just brilliant engineers. It is profoundly shaped by something much more basic, the energy infrastructure humming or sputtering beneath it all.
Yeah, China's big bet on energy abundance, it creates this playground for almost unlimited AI ambition. Scale, experimentation, go nuts. Meanwhile, the US, with its older, more fragile grid, forces its innovators to constantly think about efficiency, about conserving power, which, channels their amazing brain power differently.
And that difference, that disparity, it really shines a light on two very different national philosophies, doesn't it? Short-term individual profits versus long-term collective strength and planning ahead. So as you go about your day-to-day, maybe chew on this thought. What if the most important innovation we need right now isn't actually a new algorithm? What if it's a new way for us as a society to prioritize the long-term collective good over that immediate short-term individual gain?
Yeah, think about how the choices being made about energy right now, or maybe the choices not being made, how they're shaping not just our tech future, but our everyday lives for years and years to come.
Thank you for joining us for this deep dive. We really hope this gave you some fresh perspective, something new to consider.
Until next time. Outro music.